Some important things that we want to note about the normal distribution, or the standard normal distribution in this case. First is that we use the z-score to label the horizontal axis, and the area of the region is equal to the associated probability of occurrence. So if I'm looking at one particular value under the curve, there's no area associated with it, and so its probability would be 0. But the PDF has a height to it. So for a continuous random variable, there needs to be a range of values to consider so that we can have an area. And the way that we're going to look at using our calculator to find the area will be to use the normal CDF function on our calculator. You can also look up the values in a table. So this involves having a table of all the values that a normal curve will take, or all the areas under the normal curve, I should say. But we won't be doing it this way. Instead, since we all have calculators that will do this very easily, we'll focus on using the calculator. And so there will be 4 arguments that we're going to be putting into the calculator. So say, for instance, I want to find the probability that it's between A and B. Then we're finding the area under the curve between A and B. So we'll use A is the lower, B is the upper, and the mean and the standard deviation will be input as the 3rd and the 4th arguments. So oftentimes we'll also be looking for z-scores. So in other words, if I'm given a particular area, say I want to find the z-score that goes with a particular area, then we'll use the inverse norm function on our calculator. And again, you could also use a table, but here we're going to focus on using the calculator. And so using the inverse norm function, we're going to input as one of the arguments the area. So in this case, we're given the area, we're given an area, and we want to find the corresponding z-score. So this is what the inverse norm will tell us. It'll spit out what the z-score is for a particular area, in which case we're also going to include the mean and the standard deviation as the 2nd and the 3rd argument. For the 4th argument, you're going to input the tail. So this can take on several values. It could either be a right tail, a left tail, or center. The calculators that don't have this option, some calculators only do left tail. So in other words, kind of what we see here in the picture, it would be only the area that's to the left of that z-score would be what we're putting in here. So we can still find the area to the right, we can still find the right or the center ones, but we would have to adjust how we're entering the area here. So in the next example, we'll look at using these calculator formulas.